Right. Any questions with simplifying or adding or subtracting radicals? Now, let's do another one. Let's do distribution with radicals. Let's have you guys do number 23. Do number 23, please.
Black hole is used for time travel. Words have changed form from I to C. Yeah. And those are easy. Hold on, me and Mama do your food.
Okay, what do we do?
Multiply each term in parentheses.
Okay, so we distribute.
Distribute.
Okay, so negative 2 root 5 times negative 2 root 6 plus 3 times negative 2 root 5. Now, when I'm multiplying radicals, what gets multiplied?
What do you mean it's inside the parentheses?
The number inside the square?
Right. So the numbers on the outside get multiplied together, and the numbers on the insides get multiplied together. Okay, this is different from adding. Okay, adding and subtracting, you just are adding or subtracting the outside. The inside stays the same. When you're multiplying, the outsides get multiplied and the insides get multiplied. So what do I get when I do this one?
Oh, when you distribute, you get.
So when I multiply negative 2 times negative 2, I get what?
Negative 4.
4.
Wait, no, 4.
Square
4.
root 30 minus 2. Square root 5 times 3.
Okay, so here we go. Can I simplify this anymore?
No.
No, you cannot.
Well,
No, you can't. Yes.
Right.
oh,
There, can I add these together? Can I get negative 2 root 25 or something?
no.
No, because these are different radicals. So you cannot do anything when the radicals are different. Okay? This is the most you can do. All right. Any questions with the distribution?
No, sir.
Okay, so before we left school on the Corona break, if you will, we talked about problems like number 27, where we're multiplying a binomial radical. So remember, what is a binomial radical? It's a radical that has 2 terms. That's what binomial means, 2 terms. So this is a radical with 2 terms. Okay. So how do I multiply 2 binomial radicals?
Get that little white cord out of bed.
Y'all remember? How do I multiply 2 binomial radicals?
Don't you have to have them, like, put the same number up under the radical?
No, that's when you're adding or subtracting 2 radicals. The radicals underneath, the number underneath the radical must be the same. But when you're multiplying 2 binomial radicals, it's a little bit different. Question, how do you multiply these 2 binomials? How would you multiply x plus 2 times x plus 3? What do you do?
Foil.
The smile, not the smile method, but
Foil.
Foil, or
the
you do
foil method.
double distribution or foil? Yeah. So guess what you're going to do here?
Foil.
Foil. So remember, F stands for first. So 5 times 1 is 5. Let me write this a little bit lower so I got room to write all my arrows. Then the outsides. So 5 times 2 root 3 is 10 root 3. Remember, the outsides get multiplied, the insides get multiplied, but in this case, there's no inside. Then the inside 2 terms, and then the last. Now, how do I clean this up? Is there something I can do?
You simplify.
Okay, so when I simplify, what do I get? First of all, what can I pull out from underneath the radical immediately?
9,
9, and what does it become?
3.
3. So if you had to rewrite this, it'd be 5 plus 10 root 3 plus root 3 plus 6. Okay. Now,
And it's going to be 11 plus 11 or root 3.
yep. Any questions?
No, sir.
All right. So let's have you guys do number 28.
Nice dog.
Thank you. This is my little one.
Okay.
He's nervous. Sees all this algebra.
Oh, my dog's sleeping right here next to me. Should I wake him up?
Wake his little head ass up.
Don't wait to mud up.
Hey,
Hey, you got a mud.
Yeah, mud. Got a mud dog.
Mud bone.
are y'all even done with the problem? Because I'm done.
Smack,
So let's go ahead
smacking
and
on
get it
our
over
toes
with.
at
How do we do this?
Going forward.
You gotta do, you gotta do the foil first.
Okay, so the first terms, what is that when we multiply the first? -2 times root 4, because remember, outsides get multiplied, insides get multiplied. Then we do the outside terms. What do I get when I do the outside terms? Well,
Negative. No. 6.
6.
Well, yes. Through 2.
Then we do the inside. And then we do the last term. Okay. How do I clean this up?
And
You're gonna take out the 4 and turn it into a 2. And
Okay.
then you can combine 6 root 2 and 5 root 2.
What do I get when I combine these?
-4 minus squared.
Root 2.
Okay. And combine my numbers. Any questions with these problem types? All right. What if I gave you a problem like this? We talked about this type of problem also.
They're conjugate.
They're conjugates. Yeah, they're conjugates. What makes them conjugates?
Their signs are opposite of each other.
Right, and one they're added and one they're subtracted. So remember, these are called binomial conjugates. Now, how do I multiply binomial conjugates? I mean, you can FOIL, but what is the shortcut method? When we multiply a binomial by its conjugate, what is the formula?
What are you talking about for this problem right here?
What is the formula? When we multiply a number by its conjugate, so a plus b times a minus b, what's the formula? Y'all remember?
Oh, I did a minus b plus a. I mean, a minus b, a plus b equals a squared minus b squared.
Yeah. So it's the first term squared minus the second term squared. Y'all remember that? When we multiply a binomial by its conjugate, you get the first term squared minus the second term squared. So this would be 3 squared.
Minus,
root squared.
yeah, root 2 to the second power. Root 2 squared.
Okay, so 3 squared is?
9, my bad.
And what is root 2 squared?
Root 4 squared.
Which is?
Wait, no, root 4.
It would be 9 minus 2.
Right, because remember when you square a square root, they cancel each other. Remember, square rooting something and squaring something, they're inverse operations. They undo one another, like addition and subtraction.
Yep.
Addition and division.
Your answer as 7.
So look what happened. When I multiplied a binomial by its conjugate, what happened to my radical sign?
You get one whole number.
You get a whole number. The radical sign goes away. And that's an important fact, okay? That's something you can keep in the back of your mind when you're multiplying a binomial by its conjugate. So before we move on, let's do a practice problem.
Okay.
Solve.
Root 5.
Plus root. So decline.
Okay, so what do we get when we multiply these?
4 times 5 minus 3.
Okay, so let's walk through it. 2 root 5 squared is the first term squared minus
Root 3 to the second.
Okay, so let's do the second term first because it's easy. There's nothing really to do that. So what is root 3 squared?
Root 3 is, oh, negative 3, my bad. I'm tripping.
Okay, now let's go back to this guy. So how do we square 2 root 5? Remember my properties of exponents? What do we do with, like, say 4m squared? How do we do that? Did y'all forget? Remember when you have multiple things multiplied
Reduce the
together?
index of the radical and the exponent with 2?
Yeah, so remember you can, when you have multiple things being squared, you can give that exponent to both, everything being multiplied. So 3 NP cubed is 3 cubed N cubed P cubed. Do y'all remember that property of exponents?
Duh, that was a long time ago.
Yeah, but you can't forget, because radicals, and we're going to talk about this later on, radicals are a type of exponent. Okay?
Mm-hmm.
So guess what we're going to do here? We're going to give this exponent of 2 to the 2 and square. So does everyone see that?
Mm-hmm.
Okay. Any questions about multiplying a binomial radical by its conjugate?
So, Mr. D, for this test, like, are you gonna put it in Google Classroom and we do it like that, or we're gonna get on Zoom and you're gonna monitor us while we do the test?
I've not decided yet. I mean, I'm gonna let you know. I'm gonna let you know as I get closer to the test.
Okay.
Well, I don't need your Google Classroom code again.
All right, I'll send it to you via remind.
Okay.
All right, now let's see where I'm going to use this.
Mr. D,
Yes,
the test is going to be on Ingenuity, right?
yes.
All right.
So let's take, for example, a fraction like this. What did I say yesterday we do not want to have in the denominator?
The radical on bottom.
The radical. So how do I get rid of that radical?
Aren't you going to multiply it by its conjugate, or?
Well, not by its conjugate, but in this case, since there's only one number or one term underneath the radical.
You're going to multiply it on top and bottom.
Right, you're going to multiply both the top and bottom by what's in the radical. Now, what if I had something like this? I still have a radical underneath the denominator, in the denominator.
You're going to multiply by its conjugate.
Yes, it's not enough for me because now I have two numbers in the denominator, not just one. Okay, so in the previous problem, this
So
was
would you multiply top and bottom by 3 plus root 2?
Mhm. So the previous problem, this was just one term. 2 root 3 is one term. Remember, terms are things that are being added or subtracted. This was one term. But now, in this problem, we have a binomial. We have two terms. So it's not enough for me to just multiply by root 2, like I did in the previous problem. So here, to get rid of it, I have to multiply by its conjugate. Okay. Now, remember when we multiply fractions, we multiply across? Okay, now let's look at the denominator first. So it's 3 plus root 2 times 3 minus root 2. And when I multiply this number by its conjugate, what do I get?
They cancel out, don't they? Oh.
Yeah, the radical goes away, but what do I get? What do I get when I multiply 3 plus root 2 times 3 minus root 2?
9 plus
9 minus.
oh 2.
So the bottom becomes 7, which is good because I got rid of, finally, it enabled me to get rid of my radical, and then I just distribute in the numerator. Okay. Make sense?
Mhm.
Anyone not see what I did or why I did what I did? Okay, let's have you guys do an example problem. Simplify.
Bro, mute yourself.
Better out than in, that's what I say.
Okay. Y'all are weird.
Considering they're being recorded, so their burps are being recorded as well. So
I mean, right here. The way he was on, like, what you did.
so what are we going to multiply by?
2 root 5 is 1.
Conjugate.
So what's the conjugate of 2 root 5 plus 1?
Root 2 root 5 minus 1.
Good. Okay, so let's worry about the denominator first.
Did you work? I'm probably going to set my bed.
What do we get?
Which one is that? Is that the
That's the denominator, so what do we get?
1. Maybe not.
wait, hold on. Oh, so if that's the denominator, we're gonna get because you got it. So 4 times 5 minus 1?
It'll be 20 minus 1.
Yeah, I got 4 times 5. That's off the top. Oh yeah, I was right. Because I'm smart like that.
Okay, so the denominator is 19. Now, what happens in the numerator? So I got 1 minus root 2 times 2 root 5 minus 1.
But I got like, I don't know this right. You got like a long number. I got 2 root 5 minus 1 minus 2 root 10 plus root 2.
Okay, so the first terms is 2 root 5. Outside is minus 1. Inside is minus 2 root 10. And then the last is plus root 2. And can we combine any of those? Or simplify any of those?
No.
No, so you just have to keep every one of those terms.
Can we turn it into a decimal?
No.
Okay.
All right. Any questions? Are we good with this? Can we move on to the next topic?
Yes, sir.
All right. Right. Now let's talk about rational exponents. Rational exponents. So when you're dealing with rational exponents, when you see the word rational in mathematics, okay, this word rational is a synonym for fraction. So a rational number is a number that can be written as a fraction, okay? Can one of y'all please get rid of that stuff on the wall, please? Thank you. So rational exponent, we've had a lecture on this when we were talking about exponents in the previous chapter. A rational exponent is an exponent that's a fraction. So up to now, you've been dealing with like the square root of a, okay? And we can write the square root of a using a rational exponent, okay? Remember, there's an understood number on the outside of this radical sign. It's called the index. If there is no number, the understood number is 2.
That's not the same thing.
So
Rational
this is
exponent.
known as a cube root. So this is written as like this. Fourth root is written like this. So the general formula is if you have a radical with an index, it is the same as 1 over that index. Does everyone understand? It is important that you understand this concept, the relationship between radicals and rational exponents. So the square root sign is the same thing as raising something to the 1/2 power. The cube root sign is the same as raising something to the 1/3 power, and so on and so forth.
Are you okay?
Now, some of you are wondering, like, okay, what does it mean for a cube root? Well, remember, a square root says what number multiplied by itself gives me 16. Okay?
4.
4. The cube root of a number is saying something similar. It's saying what number multiplied by itself 3 times gives me
2.
8. And this is 2, because 2 times 2 is 4, times 2 is 8. Okay. And likewise, the fourth root of a number says, okay, what number multiplied by itself 4 times gives me this number underneath the sign?
Sure.
Does everyone understand what it means to do the cube root, fourth root, nth root, if you will? So the index tells you how many times the number that you're looking for needs to be multiplied to itself to give you the number underneath the radical. And you can write that using fractions as 1 over n, where n is the index of the radical. Okay. And remember, if there's no index, the understood index is 2. Now, can I move on? Can I move on? Now, let's look at something like this. You can have a fraction like this, a to the 2/3 exponent. And this is the same thing as cube root of a squared. So when you have a fraction exponent, the denominator is the index and the numerator is the exponent of the variable. Does everyone understand?
Yes.
Okay. Now,
Yes, sir.
say for example, you have an improper fraction. Does anyone know the definition of an improper fraction?
Isn't it like a number?
I can give an example of one.
Give me one.
7/5.
7/5. So an improper fraction is a fraction whose numerator is larger than the denominator. I can rewrite this as a mixed number. So 7/5 as a mixed number is 1 and 2/5, right?
Mm-hmm.
And this is the same as a to the 1 times a to the 2/5. A to the 1 is a, and a to the 2/5, as I talked to you about earlier, is that. Make sense? So improper fractions, we write it as mixed numbers, and you can do this. So say, for example, I have m to the 9/4. Okay. This is m to the 2 and 1/4 written as a mixed number. And that's the same as m squared times m to the 1/4. And m to the 1/4 can be written with radical signs like this. Make sense? Now, you could use this to simplify. So say, for example, I have a problem like this. Okay. Now, when I have two exponentials multiplied together, both with the same base, what do I do with my exponents? Do y'all remember the rules? What do I do with my exponents when I have multiplication with exponents?
Add.
Add the exponents. Good. Don't forget your exponent rules, guys. The power rule, the product rule, and so all that other stuff. So this is b to the 3/7 plus 9/7, which is b to the 12/7. So if you write this as a mixed number, that's b to the 1 and 5/7, which is equal to b to the 1 times b to the 5/7. So that's b. Okay. So if you have an improper fraction as a radical, rewrite that as a mixed number and break it up. Okay. Does anyone have any questions about rational exponents? Okay, nice. Any questions about rational exponents? Okay, so let me give you an example problem to do. Simplify. So what do we do with my exponents here? Do we add them? What do we do? What do we do when we have an exponent raised to an exponent? Well, okay. Multiply, yes. So this is equal to 5/3 times 2.
Joseph, mute your mic.
Okay. Now, b to the 10/3 can be written as 3 p cubed times p to the 1/3, which is p cubed times the cube root of p. Any questions? Any? Now, you can also use this with your square root property. So say, for example, you have something like this. So remember I told you to break it up and do all that other stuff? you would first break it up. And then remember I told you to say, okay, break this up, m to the 5 to m to the 4th and times m and p to the 6 times p. But you can use rational exponents. M to the 5th is that, right? And you can rewrite that as which is equal to m squared times the square root of m. Same thing with p to the 7th. P to the 7/2 is equal to p to the 3 1/2 p cubed root p. And then when you multiply them, remember the outside gets multiplied and the insides get multiplied. So you can simplify radicals using rational exponents as well. Okay. You don't have to do this with square roots because I showed you another way, but you're more than welcome to do this way if you find this way a little bit easier, or if you only want to memorize one way of solving these things. Okay. Any questions?
No.
Are we good? All right. So by the end of the day, I need the rational exponents assignment done, and I will be uploading your grades, if not this evening, tomorrow morning, first thing, once I get the green light from Slater. Okay. Well, if there's no more questions, y'all have a great afternoon. All right. And I will see you either 2 o'clock, tomorrow or 1 o'clock.
All right.
All right. Have a great day, guys.
All right, Mr. D.
Take care. Stay safe.
All right, Mr. D.